Okay, applying the Pythagorean theorem today. We're moving on to a new chapter. This is a fun one. This is a fun lesson, and you learn some tricks here that I think make your the rest of your geometry a little bit more simple. So the theorem itself, let's just get that into our notes. I think most of us know how this works, but just in case, the Pythagorean theorem, in a nutshell, it works for right triangles only. And if we label the two legs of the triangle A and B and the hypotenuse C, these guys have to be the legs, the C has to be the hypotenuse, then the sum of the squares of the legs, A squared plus B squared, always equals C squared. And there are some great visual proofs for this that we might look at in class, or even offer as extra credit, and I may try to put some extra videos up to go along with this one to show you why that works the way it does. Start with just a basic example of how it works and how you can, if you have two of the sides, you can always solve for the third. So here we've got a triangle, a right triangle with legs 6 and 8, and we want to solve for the hypotenuse. So the two legs are your A and your B in either order. So 6 squared plus 8 squared is going to equal x squared. And we're just going to solve algebraically. 36 plus 64. And then add that up. And then we're going to take only the positive square root of each side, of course, because distance can't be negative. So the positive square root of both sides. X is 10. Then just I want to show you that you can also solve for one of the legs, not just the hypotenuse. This is just another problem from your book. Put it as another example. If I have a leg and the hypotenuse, but I want to solve for the side. So again, the sum of the squares of the legs, x squared plus 3 squared equals 5 squared. I can still solve for x squared. X squared plus 9 equals 25. Subtract 9 from both sides and take the positive square root of both sides. That's stuff you already knew, I hope. Your book introduced one other kind of problem I thought was kind of a good practice of this theorem, and it was finding the area of an isosceles triangle given certain information. So what if I told you we had an isosceles, I wanted you to find the area of, and I'm going to abbreviate somewhat in here, of an isosceles triangle with side lengths 10 meters, 13 meters, and 13 meters, and use the Pythagorean theorem to find that area. Let's start with a sketch. So if we had an isosceles triangle, obviously the two 13s are going to be here, and the 10 is going to be there. But if we're going to find the area, we're going to need the altitude, and then it just so happens that the altitude in an isosceles triangle is also the perpendicular bisector, which gives me this and this. So again, applying some things that we learned earlier. So if I know that, again, to find area, I need to find this. We'll call it h. Now I have two right triangles that both have h as one of the legs. So I can just apply the Pythagorean. 5 squared plus the height squared equals this hypotenuse. So again, just going to solve that. Subtract 25 from both sides, and h is 12. I am going pretty quick through this kind of stuff. You can always pause if you need to and rewind, but the algebraic solving, I think our group is ready to go with that. So 12, the height is 12 meters. One more step for this problem though, area of a triangle is half times base times height. So we're going to go ahead and plug in what we know. 1/2 the base of the triangle is 5 plus 5, or 10, and the height, we just did all that work to find out, was 12. So half of 10 is 5, and 5 times 12 is 60 square meters is the area of the triangle. All right, and here's where I think the lesson gets pretty fun. And that's discussion of Pythagorean triples. Sorry, I disappeared for a second. Pythagorean triples. What's a triple, you might ask? And I might tell you. Pythagorean triple. Okay, these are 3 positive integers that satisfy this guy, the theorem. And they come up again and again in all kind of situations, especially those crafted by textbook writers. I suppose we don't hit too many Pythagorean triples in real life, but it sure is handy when we're solving problems and practicing some of these skills. So here is what I mean by that. There'd be no decimals or no radicals. They would fit perfectly into this. Some of those triples are, and you just saw some of them in the problems we just did, 3, 4, and 5, meaning the two legs 3 squared plus 4 squared equals 5 squared. 5, 12, 13. 5 squared plus 12 squared equals 13 squared. 8, 15, 17. And yes, you're writing all these down. 7, 24, 25. And 9, 40, 41. Look at this. Bonus feature. Only on the video, not listed in your book as a triple. So you're thinking, so what? Right? Well, we're going to work on problems in class that use these like crazy, but it just means that if you see a triangle somewhere and you recognize 2 parts of the triple, you can write down the third part without doing any work. You just know it's the third number in the triple. Now, you don't have just these triples either. You could so a triangle could be 3, 4, 5. Why couldn't it be 6, 8, 10? I just multiplied each of these by 2. Or it could be multiplying each by 3. 9, 12, 15. Your book lists all these out. You really just need to memorize these. If you can memorize those and recognize them quickly, it's kind of like it's gonna help you in the same way that knowing your multiplication facts by heart would help you be quicker about solving these kind of problems. So let's look at a few problems where we could apply this. I just want to throw one other thing in here. Besides being able to recognize the triple and recognize multiples of the triple, you could also recognize that you could divide these in half too. So if you happen to see a triangle that for some reason had 3 halves, 2 and 5 halves, we can do all kind of things with these triples. And again, we'll be practicing and practicing in class. But I did pick a couple of problems for us to look at. So first one we just, I think, already looked at. But let's think about that 3, 4, 5 triple. So if I have 3 and 4 and I need to solve for x, and I know that the right triangle is here. Again, all of these triples, this last guy here, the longest one, is always the hypotenuse, right? Okay? So if I'm given a triangle 3, 4x, x is 5. I don't need to sit there and say 3 squared plus 16 squared equals x squared and do all that work. If I have those memorized, x is 5. What if I had a triangle that looked like this, and I was given, let's say, 40, and I was given 85, and I had to solve for x? You just sort of start to learn how to play with these numbers. So I see that both of these are divisible by 5. If I divide this guy by 5, I get an 8. And I'm going to circle it. If you get in this habit, when you have the numbers that are circled, then are going to be the triple. Sometimes you might do this and you might not find the triple. But let's just start by dividing by 5. If I divide by 5 here, I get 8. If I divide by 5 here, I get 17. And I see, well, I happen to know the triples. I recognize a triple. Because 17, 8 and 17 right here. 8, 17, that other leg is going to be 15. Now, it's not going to be 15. I'm going to put 15 in the circle. Okay? But then I look back and say, okay, what did I do to the triple to get it to be the actual triangle? I multiplied by 5. What did I do to get from the triple to the actual triangle? I multiplied by 5. So what do I have to do? Multiply by 5. 15 times 5? 75. X is 75. And of course, if you had a calculator, you don't even need to do that. Let's look at one more. And I want you to really try to use these triples tonight or in class, I should say, when you're doing your practice problems. Here's another triangle. I have 12.5, and I want to solve for x. Now, I could divide both of these numbers by something, but I see that decimal. Let's just see what happens. What if I multiply them both by 2? If I multiply this by 2, I get 25. If I multiply this by 2, I get 24. I recognize a triple because I have them memorized. This guy right here, I recognize that 7, 24, 25 triple. So that means if I put the 7 in the circle here, okay, that's going to be used to get this x. What did I do to the triple? I divided by 2. What did I do to the triple? I divided by 2. What do I do to the triple? I divide by 2. Or the decimal, 3.5. Okay. More practice on this in class.